number 8, comparison trees, random forest and boosting with highlighting their strengths and weaknesses. So let's start with the simplest model, the decision tree. A decision tree is a super easy and to understand and visualize. It can handle both numerical and categorical data. It doesn't need features like scaling and even capture nonlinear relationships. But there are the catch, the decision tree overfit easily. The small screen data can change the entire tree, making it unstable and compared to ensemble methods, it is accurate. Its accuracy is relatively lower. So yes, simple and interpretable, but not always reliable. Moving on to the second, we will be talking about random forest. So think of a random forest as a team of decision trees. Instead of relying on just one tree, it combines many of them to reduce overfitting. This gives higher accuracy, better robustness, and good performance even with the noisy or missing data. But it is not perfect as random forests are harder to interpret, and because you lose the simplicity of a single tree, uh, they also train slower since they build many trees and they require more memory and they occupy more memory in the system. So they are accurate but not lightweight. We can see it like that. So then let's talk about boosting like ADA boosting and XG boost. So boosting builds models sequentially where each new model focuses on the mistakes of the previous one. So this makes it extremely powerful. In fact, boosting models win most ML competitions. So they reduce bias a lot. Uh, and provide high value accuracy. And but boosting can overfit if not regularized properly. So it also is sensitive to noises and outliers and can be more computationally expensive than random forest. So powerful but needs careful tuning. Now moving on to the question number B, question number 8 of B part. So how basic question number 8's B part. So how basic logistic gates can build using single layer neural networks. So let's take a single layer perceptron can compute logic gate using output f into the w1 x1 plus omega 2 into x2 plus b. So here's what a single layer network can do. It can perform AND or an AND or NOR. All of this can are linearly separable. So the neuron is enough. For example, AND gate can use weight of mu1 is equals to 1, mu2 is equals to 2, mu2 is equals to 1, or bias is equals to minus 1.5. OR gate can use bias is equals to minus 0.5. But there are one famous gate a single layer cannot solve, which is XOR gate. So the XOR is not linearly separable. You cannot draw a single straight line to separate the classes. Also, XOR requires multiple neurons and a hidden layer, which means backpropagation is needed in the XOR gate. So this was all about the gates and the how we can build using single layer neural networks. The complete table of the gates are given by this. The gate are AND, OR, NAND, NOR, and XOR. The number of neurons in AND is 1, in OR is 1, in NAND is 1, and NOR is 1. But in XOR it is 2 plus neuron plus hidden layer required. The activation function is simple. It is by everyone is by sigmoid or ReLU, and the backpropagation needed for AND or NAND or non are there are no backpropagation. But yes, there is backpropagations when needs multiplayer networks and